4-3. Okay.
That's why you come so often, right? Yep.
Okay, we spent 2 days on that binomial distribution. Now we're going to talk about 2 others. And I've got the 2 mixed up today, so it's not going to tell you which one's which. You're going to have to be able to pick out, based on the probability question, which one it is. So the first one we're going to talk about is called the geometric probability distribution. Yep. Geometric probability distribution. Here are the conditions. With binomial distribution, we knew exactly how many trials we were doing, and we looked for how many successes we had. With geometric, you repeat trials until you get your first success. So you don't know how many trials it's going to take. So repeat trials until a success happens. Oh. Success happens. Okay. Each trial has to be independent of the next. So in other words, the first trial doesn't affect the second one's sample space. Just like binomial, the probability of success has to be the same on each trial. And in this one, where x was the number of successes we had in binomial, now x is going to be the trial number where the first success happens. So x will represent the trial number of the first success. So, our formula for this, that gives, so, the probability that the first success happens on trial number x is given by this formula. P times Q raised to the x minus 1. So it's a little bit easier formula. So I've got one example with some parts, 4 parts on this one. Then we do the second probability, one example, and then you get to the homework. Because you've got that list process all down, so we don't have to learn that now, but we're still going to be using the list stuff. So, our example here, and I'll try to pick out the stuff that makes it geometric and not binomial. So we've got a telemarketer. Great job to have. Just kidding. Has the probability of making a sale on a call to be 23%. Find the probability that the first sale happens on the third call. Okay, so it's all about where they ask or how they ask the probability question, which distribution it matches up with. The key word in here, find the probability that the first sale, that's the indicator that this is the geometric. It's not saying she made 15 calls, what's the probability she makes 7 sales. That would be binomial. So first time a success happens, third call, that's geometric. So we are looking for the probability that the first success happens on the third call. So there's our X value. The trial number is your X value. Our formula says P. What does P represent? Probability of success. What's the probability of success for this person? 0.23. Multiplied by, what would be the Q value? 77. Raised to the X minus 1. Or just 3 minus 1, you can put a 2 there. So with this problem, I wouldn't bother making a table. It's just one probability. So you crank through that.
So can you just put that all in one line, or like?
Yep, that can go all in one line, nothing special needed.
Okay.
.136, I'm hearing a couple of times. Okay, same situation. Find the probability.
Are you sure you don't have to type it in like that?
Nope. 0.23 times 0.77 raised to the...
What? No, you don't need
Yes.
parentheses.
For your calculator, you do. Always put parentheses. Just do it. 3.
Well, if anything, you would need them here. Otherwise, just put in a 2.
That was good.
It all depends on your calculator. Okay.
It also depends on the person.
Find the probability that the first sale happens before the 5th call. Okay. First sale is my indicator that this is geometric. Before the 5th call. So what probabilities am I looking for? What are the trial numbers where the first success has to happen? Either on the first trial, or second, or third, or fourth. Before the 5th. So, on a quiz or a test, I guess I need to talk about what I need to see. So in case you make a mistake, I need to know how much partial credit to give you. Because if all you do is do everything on that calculator, I don't know whether you used the right formula. I don't know whether you added up the right probabilities. So I would like you to, X is under 5, or I could say less than or equal to 4. I don't care how you write that. Then use your formula. It would be 0.23 times 0.77 raised to the X minus 1. Where we're going to put X's, what X's are we going to put in a list? 1, 2, 3, 4. So go ahead, put 1, 2, 3, and 4 in the list. Then go over to list 2 and use your formula. And all we're gonna do is wherever you see an X, you're gonna put L1. So 0.23 times 0.77 raised to the L1 minus 1. And you're gonna have to write these on the test for me. Even though we can get the list to add them up, I'll never know how many you added. Do I know that you know not to include the 5 here if you write this down? I don't know that.
Should these be negative in this too? Probably.
Is the probability, what?
Whoops.
No, probabilities are never negative.
Make sure you put parentheses, on your L1 minus 1.
Yeah,
Yeah, so that was my wrong. Last night, that's what I was doing, too, that was that. I got my.
You're gonna have to give me those so I know so I know how many of the probabilities you added up. And then you can get the calculator to add them for you using your list math. I know. So that is what I would need on a test for me to give partial credit.
Or just get it right and then not have to worry about it.
That doesn't always happen. Because you get points for picking out the right distribution, so I need to see the formula for your points there. Then did you put in P and Q right? And then did you get the right number of probabilities? So there's like 4 points there.
You're rounding off, which would be 0.648.
I didn't even look. Did I get it wrong? Is it 8.5?
Yeah, it's eight.
Okay. All right. Try another one in here. Okay, this is the last one here. Find the probability
Find the probability.
that the first sale happens after the 6th call. Well, let's make it smaller. Let's say after the
Sure.
3rd call. We'll make it a little smaller. After the 3rd call. Because the process is going to be the same. So what does that mean? Where am I looking for the first success to happen? 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, infinitely after the 3rd call. Can we make a list that's infinitely long? No. I mean, eventually those probabilities are going to get so small that they're going to be zeros. How do we get this one? We only have one way to get it now.
1 minus.
1 minus.
Minus infinity?
That is after the 3rd call would be 1 minus, which ones?
Oh, 1, 2, 4. The 3, 1,
1, 2, and 3. So I would need to see the 3 probabilities in here. We've already got them, because we got them right here. This was the 1, this was the 2, this was the 3.
2. Do you have to add 0 though?
You have to have a trial number. There is no 0 in
What
geometric.
if somebody does call?
You got to have a trial number.
No, he calls. The number.
Yeah, so it doesn't start counting until they make a call. So the only way to do the geometric ones, because there's no end to it, is the 1 minus. All right. Our final distribution of the chapter. Are we good? Oh, anybody have an answer?
4, 5, 6, 5. Hey, I like this
when you're happy.
I just shout.
No, I haven't actually feel like crap, but I mean.
Yeah, that makes sense for having ADD. Keeper at for bear on. I don't think what's
Oh, leaving?
Why don't you go down and turn the ping pong? You're trying to get a Pantene commercial?
What? Oh my
That's
God.
poison, am I right? Yeah, Pantene. Halcyon. Poisson.
L'Oreal.
Smells like.
Poisson.
L'Oreal. Oh, yeah, no, perfect.
You too good in English, class.
Yes, I did.
Are you sure?
Black Side, she's actually supposed to be an English teacher.
Suck it. Oh,
Maybe. Let's see. My head's a little stuffy today. I'm going to blame it on the stuffy head. Finds the probability that a specific number of occurrences take place within a unit of time or space. Alright, there's 3 conditions here. First of all, X is going to represent the number of occurrences. Within. Well, come on, texting generation.
I don't really pet the word within.
Oh, nobody says within?
Yeah.
X is the number of occurrences.
Go buy a pair of Timbs.
The probability of the event happening is the same for each interval.
I think you know what you could think of another. What? You say you... Yeah. How was your AJ? Just misspoke. You know what the most astounding is?
Okay, so there's our condition. Alright, so now the formula. So the probability of X occurrences if mu is the mean number of occurrences for the interval. So this is the only the other 2 distributions give you the probability of success. Poisson tells you what the average number of occurrences is for a time unit. Like say, they did some statistics on me for the 23 years I've been here. They could say on average Mrs. Schwartz takes 3 sick days per school year. So that's my average. So then they can say, oh, what's the probability Mrs. Schwartz is going to take 10 sick days next year?
Extremely high.
Very low. But so they can do stuff like that. So it's the mean number of occurrences per unit of time or space. So the formula is the mean raised to the x times the constant e, which is on your calculator, and I'll show you that, raised to the negative mu, all divided by x factorial. Of course. Nice little easy formula for you to work with. You might want to make a note card, Keeker, because I don't think you got this without writing them down. I don't think these are pretty straightforward anymore.
It's already in there.
In there.
Let's just wish you
Yeah,
had a
photographic memory. Life would be so easy.
Okay? Are we good? Casey, you good?
Yeah, this is much
Okay.
better. You like that string?
Here we go.
No, you watched Tesla.
I watch string theory.
Wait, that was fun.
Where they relate everything in
3 days of those videos at something week product.
3 days of those videos? Oh no.
Tesla. That was not a good time.
Tesla was bad because we already watched it.
Yeah, I know.
We watched it at the beginning of the year, so we were just really watching it again.
And then those Khan Academy videos were like, what?
Those videos were awful. They were 240p and you couldn't understand anything that was on the screen. We're gonna have a quiz on them.
You're not gonna be as thrilled as I was, but you might be amused, but I was still.
It might be in the age
It's an acquired taste that I'm
not
to acquire it.
I think it's gonna go on my.
Are you? Actually, there's a special with Pikachu and it has like a special
We're having this
Like what?
conversation and they're having that conversation.
Okay, let's get through this last example together. So the mean number of accidents per month at this particular intersection is 3.
That's a lot of action.
That's a lot of accidents to happen per month at an intersection. I think they need to put in a roundabout.
Yeah.
I don't like that.
I hate them, hate them, hate them, hate them.
They're so awesome, you can just fly through them.
Yeah, I actually like
them. So cool.
I don't like the real busy ones, like in Green Bay, those ones on Mason, they move.
You go on like the inside, you're done.
I know, I hate those. The non-heavily traveled ones are fine, but
Wrong turn, you end up in the wrong neighborhood.
I know, dang, gotta go around again. Yeah.
Colorado is the highest lane.
Oh, see, that would just put me over the edge.
7 times.
Where was this?
Someplace in Colorado.
Oh, that's funny. Yeah, those 3-lane ones are the top ones. I'm like, ah,
Oh, God.
hate them. Okay.
Why is it 5 lanes? Oh, wait, never mind, that makes sense.
What?
Yeah, you really gotta watch the sign coming in to know where you wanna go and which lane to be in. Otherwise, you're like cutting people off. Anyway.
Is that a bad thing?
No, it's a bad thing. Okay.
Give them the universal peace sign.
Keep going.
Okay, ready?
Yeah.
Stay with me 5 more minutes. The key word in here that makes this Poisson, listen.
Taylor.
Mean. That tells us Poisson. Okay? So they're giving us a mean. The binomial doesn't give us a mean. The geometric doesn't give us a mean. Only the Poisson. So the mean number of accidents per month, that's our time interval, is 3. So that makes our mu value the 3. And notice the question has to be for the same time interval. Per month, next month. So those have to match. So, first question, what's the probability that there are 4 accidents next month? So we're looking for exactly 4, so it's only the one probability. The formula that I gave you earlier was the mu, which is 3, raised to the x, which is 4, times e raised to the negative mu all over x factorial. So maybe you want to write down that mu is a 3 here, x is 4. Let me grab a calculator.
Does E stand for something like how pi is like a number?
Yes, E is a constant like pi is a constant. Okay, your E is, where are you? I believe you're right here in blue. Second divide, or alpha divide.
Okay, we also use the one with the L.
Where is it?
It's right up, it's 2 above on.
Oh yeah, it's got an exponent on it too. Yeah, you can use that one too. That'll be better. We don't have to use the caret key.
Oh, found
More
it.
factorial. Where's factorial?
Factorial is under math and probability. So 3 raised to the 4th times E raised to the negative 3rd divided by 4 factorial.
Using the what? Negative 3rd.
17% chance. 0.168. How'd you do?
Hang on, we're almost there. Alright. The green line we did.
That's the same one you use for like the PERT formula.
Boom, I got it.
Yeah, the E is the same one in the PERT formula from advanced algebra. That's that base of the natural log.
Yeah, I forgot last time.
Okay, try another one here. Find the probability that next month there are no more than 3. no more than 3 accidents next month.
I think you make that happen.
Okay. So what values is X taking on here if I'm saying no more than 3?
1, 2, and 3.
1 and 2 and no.
Or 0.
Oh, it's 0. Could there be no accidents next month?
Yes.
The ac-
Not if I'm on the road.
So-
No, that average.
So, the Poisson can have a 0 X value, the binomial can have a 0 X value, the geometric cannot. So 0, 1,
2.
2, we're stopping at 2, or are we including 3?
We're stopping at 3.
Including 3. We need those 4 probabilities added up. So this would be a good one to use the list. So it's mu raised to the x, e raised to the -3rd, over x factorial, and our x's are going to be our values in L1.
That's gonna take forever.
So we're going to put in 0, 1, 2, and 3. 0, 1, 2, 3. Clear. And then we're going to put in our formula. 3 raised to the L1 times e raised to the -3 divided by, you don't need parentheses, L1 factorial.
You're right. Oh, that's true. Hopefully you did it right.
Factorial.
No.
Yeah.
The last one.
Oh, boy,
Wait,
it
wait,
didn't
wait.
do it right. Uh-oh.
Anybody else?
Never mind.
No, I got it.
Yeah.
Okay.
Rubber ring.
Yeah.
Oh, same one on the end. 2, 2, 4, 0. And then I'll just have the calculator sum up L2. Where is that? Math, no, list, math, sum, L2. Pretty good chance. Okay, your assignment is a worksheet.
Wow, this is a wonderful Friday.